Hey all, today we're going to continue on our journey through confidence intervals. So far we've talked about confidence intervals for proportions, for two proportions, and for sample means. And so today we are going to talk about two sample means. We are going to look at two different samples, and we are going to see if we can estimate the difference in the means from those two groups. So a lot of this is going to look very similar to what we've already done. So hopefully you're getting in the habit of justifying that you can create a confidence interval, calculating the confidence interval using the correct test on your calculator, and then of course interpreting your confidence interval using your confidence level, the context from the problem, the parameter you're interested in, that means proportion or mean, and then stating the interval. So we're going to do a two-sample t-interval. Remember, when we have means, we have t-curves. Those t-curves aren't exactly normal, but the larger your sample size, the closer those curves will get to be normal. And so the structure of our interval should look the same as the other intervals we've done. So we have a point estimate. So this is the difference in two sample means. So we have sample 1, sample 2, and we subtract the means to find the difference for those particular samples. And of course we have our critical value, our t star, and we have our standard error. And so this would be a standard error for x bar 1 minus x bar 2. This standard error you can find on the formula sheet. The general confidence interval formula you can find on the formula sheet. Calculating t star, calculating the degrees of freedom for t star when we have two sample means is complicated. The formula for that is in the book. I can show it to you if you'd want me to. We can talk about it, but it's not something we're going to want to do by hand. Typically, the degrees of freedom are the sample size minus 1. That's not the case here. It's really complicated. So what we're definitely going to do is we're going to use the calculator to make this confidence interval. That's what you should be doing anyways. Use the calculator. You need to understand what the interval is. You need to understand how to find a t star for one mean, how to find z star for proportions. But in this case, that becomes really difficult. So we just use the technology because it can do it for us. So assumptions and conditions will look the same as last time, except now we have to do it for two different groups. Always need randomization. We always need independence. Each group needs to be independent, and then the groups need to be independent of each other. And then we need to check that our data is approximately symmetric for both groups if we don't have a sample size of about 30 or more. We're looking for 30 or more. If it's less than 30, then we need to look at the distribution of the samples to see that they are approximately symmetric. The smaller the sample, the more symmetric you want it to be. So same as one mean. So we are going to, I'm going to show you a problem just like we've been doing. We'll go walk through a problem, and then I'll have one for you to answer some multiple choice questions on. And then, of course, if you have questions of me, please ask, and practice is always the best way to get better at this and get used to it. So take a minute and read this scenario about driving to work, and then we will construct a confidence interval. So when you're new to a place, you want to find the best way to get to work, and so this person is taking two different routes to get to work. We need to justify that we're allowed to create a confidence interval. So let's talk about the randomness portion. He's flipping a coin, and that coin is telling him which direction to go. So that is a random way to assign which route to take each day. So we are using random assignment. We're not sampling anything here. We're not like randomly sampling people, but we are randomly assigning ourselves to take either route A or route B to work. And so we have randomness involved. Certainly, the time it takes to get to work each day is going to be independent every day. Things will change, but they won't affect how long it takes you to get to work on Monday is not going to change how long it takes you to get to work on Tuesday. And both directions are going to be independent of each other. How long it takes you to get to work going one way is not going to determine how long it takes going the other way. They're going to be independent of each other. So we have randomness, independence, and of course, 20 days a piece is less than 10% of all the days this man will probably drive to work. And then we need to check sample size. Well, our sample size for both groups is 20 days. That's less than 30. Not really big, kind of close to 30. We don't have the data and we don't have the histograms, but what's really nice about this problem is that it tells us the histograms of the travel times are roughly symmetric with no outliers. So that means these distributions should be approximately normal. We can create a confidence interval. And of course, when you're doing this yourself, you're writing all those things out. I'm trying to save us a little time as we discuss this. I can write them out for you in class if you want me to. I always like to document the information I have, so I'm going to go ahead and do that real quick. So we have all the necessary information for both routes. We have the sample size, the sample average, the sample mean, and then the sample standard deviation. Remember, these are the standard deviations for the samples. 3 minutes is the standard deviation for the sample for route A. 2 minutes is the standard deviation for the sample for route B. If we wanted to look at a distribution of sample differences for these two samples, so if we kept taking samples, taking means, and subtracting them, and we wanted to know the standard deviation, we would need to use this standard error formula. Okay, two different things. We can find our point estimate. So our estimate for the difference in these two samples, or in these two routes, I'm going to go for a positive. So I'm going to do route B minus route A. So from our sample drive times, the average difference is 3 minutes. So that is the point estimate. So that would be the left side of our confidence interval, but of course we're going to use the calculator. So we are going to go and do a 2-sample t interval. So I'm going to pull up my calculator over here, if I can get it. And I am going to click Stat and go to our tests. We want to make sure we click the right one. We want to do a 2-sample t interval. Make sure you select t. And if we had data from the samples, we could choose the data option. They would be in lists, and then we could tell it which list to use, and it will do all the calculating for us. We have the statistics from the samples. I'm going to do B minus A so that I get a positive answer. If you do A minus B, you'll get a negative answer, but that won't be wrong. You just have to interpret it correctly. So I'm going to tell it my information for route B and then route A. Tell it your confidence interval. It's going to ask you this thing pooled, yes or no. Don't worry about it. Just click no. Don't worry about what that means. Just click no for now. And we get our interval. So of course we don't just want the interval, we want to interpret what does this interval mean. So we need to make sure we hit all the points. What's the confidence level? What's your parameter of interest? What's the context? What are we talking about? We're talking about drive times to work, average drive times, and we want to always put our interval in there. These are quantitative data sets, so we should include the units. Here our units are minutes. So I'm going to go ahead and write my interpretation, and then we can chat about it. So these are average minutes, about 1.36 minutes, about 4.64 minutes. We did B minus A, so that means the average time for route B is more. than Route A. If you had done it the other way, you'd get negatives, and that would just mean that Route A is less than B. So just make sure you phrase your explanation that way. So we're 95% confident that the mean travel time for Route B is between 1.36 minutes and 4.64 minutes longer than Route A. So we hit the confidence level, we hit the context, we're talking about means, that's our parameter of interest. I used the units. I made sure you always, whenever we're talking about two groups, we want to make sure we compare them. So we want to use comparing words like longer, more than, less than, shorter. So make sure that you're comparing the two groups. So as always, we justify that we can do this. We make the calculations, and then we interpret the three major steps in talking about a confidence interval. As always, if you have questions, please ask me. Doing some practice is the best way to get better at this and to get used to things like writing the explanations. I do have some questions to be answered about another problem. You're going to have to put this data into a list. So you're going to hit stat edit. And then you're going to enter some stuff into lists. So you can make this like list 1 and this list 2. And there'll be some questions. So make sure you answer those questions. If you have questions, again, please feel free to ask. Good luck.